Hello everyone, I'm Grishma and my the topic for today is the development and evaluation of the nanofiber based gel for the topical drug delivery of meloxicam. Now, as we know, meloxicam it is a BCS class 2 drug and it faces a lot many solubility issues and therefore it has to be incorporated into a nanofibrous matrix to increase its solubility and therefore leading to a faster anti-inflammatory action. Now, since meloxicam it is a PCS class 2 drug, it shows a poor bioavailability. It also shows undesirable side effects, slow onset of action, and also it cannot its concentration cannot be maintained at a steady state in the blood or in the plasma. So the main objective is to prepare the nanofibers of the hydroxypropyl beta cyclodextrin with the polyvinyl alcohol, which is followed by the introduction of meloxicam into the nanofibrous matrix, and then it is followed by the evaluation of the novel nanofibrous formulation containing the meloxicam for the drug release as well as solubility. Then this meloxicam loaded nanofibrous matrix is however converted into a topical formulation and also evaluated for parameters such as viscosity, spreadability, pH, etc. So the nanofibrous batches, there were total 7 batches which were however prepared. So the first batch it involved the concentration of 2% of the polymer and therefore it had a very low viscosity and therefore the fibers were not obtained. Even in the second batch, when the polymer concentration was increased to 4%, it still had a low viscosity and therefore the fibers were not obtained. And not only that, in the third batch, the polymer concentration was increased to 6%. A few fibers were obtained, but the peeling off of the film became very difficult. But when the polymer concentration was increased to 10%, it gave good nanofibers, but some of the droplets fell on the ground. So that time it was important to increase the flow rate. So when the flow rate was increased from 0.12 to 0.23, keeping the concentration of the polymer at 10% only, good nanofibers were however produced with the smooth surface and no droplet fell on the ground. The sixth batch had the same concentration, but when the flow rate increased, the nanofibers were produced, but again the droplets fell on the ground. And when the polymer concentration was increased to 14%, the solution was so viscous that bombarding such a stream of the mixture was found to be difficult. So therefore, the fifth batch was found to be uh, very useful, and they it was a successful batch giving a good nanofibrous matrix. So now, these nanofibers they were, however, evaluated for various parameters such as the entrapment efficiency, which was 92.5 to 95.2%, which is quite a good entrapment efficiency, and also it was analyzed by FTIR. So, since meloxicam, it has the NH stretch and SO stretch and CC stretch were observed in meloxicam. These stretches, they disappeared when it was loaded into the nanofibers, and this indicates that the meloxicam was successfully incorporated into the hydroxypropyl beta cyclodextrin nanofibers containing polyvinyl alcohol. And also it was tested for its solubility, and it was found to have 47 to 50 folds greater solubility as compared to that of meloxicam. Also, the scanning electron microscopy was however performed. So the Planck nanofibers without the drug, they showed a good morphology, and when the meloxicam, they showed thread-like elongated structure, the nanofibers, and when meloxicam was loaded into the nanofibers, there was no change in their shape. They were elongated and thread-like structures. Um, and not only that, also the X-ray diffraction was however carried out. It was found that the crystallinity of the meloxicam was reduced when it was incorporated into the nanofibers, which ultimately increased the solubility and the drug release properties of meloxicam. Also, the DSC, that is the differential scanning calorimetry, was however performed in the meloxicam loaded nanofibers, which also was found to decrease the crystallinity and giving an amorphous solid, which ultimately increased the solubility of meloxicam. Then after formulating this meloxicam loaded nanofibers, it was then evaluated for their pH, their viscosity, their spreadability, and also for their drug release properties. So first, the pH was found to be 6.5 plus or minus 0.15, which is quite in the acidic range, which is equivalent to the pH of the skin. It found to have an optimum viscosity with a spreadability of 70 to 0.23 gram centimeter per second, and also it also showed a good stability, that is a 3-month stability testing was however done, and it showed no change in the appearance, pH, as well as the drug release. And the topical gel, it was evaluated for the in vitro drug release by using the France diffusion cell. So if we see here, the orange color line, it indicates the crude drug meloxicam, the drug release of, and the drug release of the crude drug meloxicam is the orange color line, while the blue color, it indicates the meloxicam loaded nanofibers. So as we see, the meloxicam loaded nanofibers, they were found to have a better drug release and enhanced drug release as compared to that of the crude drug of meloxicam. And the after formulating, when formulating the meloxicam loaded nanofibers, carbopol with preservatives, that those are the parabens, the methyl and propyl paraben, and the triethanolamine and distilled water were however used, giving a topical gel which could be applied on the site of pain and therefore relieve the pain, especially during conditions such as the rheumatoid arthritis. So therefore, we can conclude that the polyvinyl alcohol hydroxypropyl beta cyclodextrin nanofibers, which contain the meloxicam, was however successfully fabricated, and also these nanofibers, they enhance the drug release properties of meloxicam, and hence the topical gel formulation of meloxicam loaded with the loaded polyvinyl alcohol hydroxypropyl beta cyclodextrin nanofibers is very useful to relieve the pain due to the rheumatoid arthritis. Thank you.